Good morning and welcome back to Math 098. So last class we started talking about factoring. We described the fact that our first step of factoring, no matter what, is GCF. GCF. Seriously, keep that in your mind, like not even kidding. You want to make sure that you factor out your greatest common factor first before you use any techniques, because potentially you won't be able to use certain techniques until you factor out the GCF. So that's something you really need to make sure that you keep in your mind. Recall that if your leading term is a negative, you're going to factor that out. And recall that there are two parts to every term. Good morning, Johanna. A numeric and a variable part. So we want to keep track of all of those things as we factor our polynomials. We are now ready to move into step 2. Recall that you have a flow chart. I would like you to have that flow chart handy so you can see the steps that we're taking and how we're building on the knowledge needed to actually implement that flow chart. Okay, so let's take a look at step 2, which is factor according to the number of terms. We're going to start off by looking at what happens when we're trying to factor 4-term polynomials. So notice here that it says a factor by grouping. So when we see 4-term polynomials, we're going to think of grouping them into groups of 2, right? So if you have 4 people, you want to say these 2 and these 2, and you have your 2 separate groups. That's kind of how we want to move through. Sometimes you have to rearrange the terms in a 4-term polynomial so that you can factor by grouping. Oftentimes, especially in this class, I'm not trying to trick you, so I will present to you a 4-term polynomial, and you will say, okay, let me factor by grouping these 2 and these 2, okay? What I want to do is I want to show you an example first. I'll give you, 30 seconds to write it down. So don't write anything down yet. Just watch, okay? Pens and pencils down. Just watch this problem. I'll give you some time to jot it down. If you're watching this later on, just pause the video, okay? So let's take a look. We have x squared plus 2x plus 6x plus 12. We have 1, 2, 3, 4 terms. If in your minds you're saying, well, 2x plus 6x is 8x, I will say, yeah, sure it is, but that's not the point. So I've given you a 4-term polynomial that I want you to factor by grouping. So I'm going to illustrate to you what grouping looks like. So here are the steps. I hope that your pens and pencils are down. We are going to identify the first 2 terms. We're going to put them in a group. And then we're going to look at the last 2 terms and we're going to put them in a group. Now, what we're going to do is we are going to pretend that we do not see the second half of the polynomial. So I only have x squared plus 2x. If someone said to me, hey, Dr. Santiago, can you factor x squared plus 2x? I'd say, yeah, duh, because we would just take out our GCF, which is x. Notice there's a variable part and a numerical part. In terms of the numerical part, you can only factor out a 1 because we have a 1 here and a 2 here. But in terms of the variable part, we have an x to the second and an x to the first. So I know I could definitely take out an x to the first. So check it out. I take out an x to the first just from these 2 terms. Remember, these 2 do not exist right now. I'm going to try and cover those up a little bit. So we're looking at just x squared plus 2x. I factor out the x, and that leaves me with x plus 2. Double check. X times x is x squared. X times positive 2 is a positive 2x. Perfect. Next, I'm going to look at just my 6x plus 12. But notice there's a plus sign in between. Whatever sign you see here, I'm telling you, you've got to bring it down. Okay? You have to bring down whatever sign you see here. So you might as well just get into that habit now. So we have 6x plus 12, a numeric part and a variable part. I notice right away that I can take out a 6. I can divide out a 6 from both terms. So I'm going to do exactly that. If I divide a 6 out of both of these terms, I'm going to be left with x plus 2. Double check. 6 times x, 6x. 6 times 2, 12. Now, what I'd like you to notice is that, good morning, Patrick. I would like you to notice we started with 4 terms. When I put them into 2 groups and I factored out each of their corresponding greatest common factors, notice now I have 2 terms. So I cut that in half. I went from 4 terms to 2 terms. Now remember yesterday's class when we recognized that we can factor out an expression from 2 terms. Notice here, we have an x plus 2 in our first term and we have an x plus 2 in our second term. So I'm actually going to factor out my x plus 2. And if I factor out the x plus 2, that means I divide it out of both terms. I'm going to be left with x plus 6. And guess what? This is one term. Remember, terms are generally separated by addition and subtraction. This is a quantity times another quantity. This is essentially a times b, and a times b is one term. All right? 4 to 2 to 1. Factor by grouping. 4 to 2 to 1. Hopefully that's helpful in that we break it down in that sense. You go from 4 terms to 2 terms to 1 term. Take 30 seconds, go ahead and write down this problem. All right, so that was our example, right? Now let's take a look at a problem where we have to really think about each of our steps. So factor completely, obviously. You're never going to factor partially. That doesn't make sense. And then we're going to check the result. I'm not going to do that for every single one, but I will do it at least for the first 2. I have 3x squared minus 15x plus 6x minus 30. Recall the steps to factoring. So I'm going to go ahead and show you my flow chart. Steps to help you factor polynomials. Is there a GCF? Is it a leading negative? Let's check. So for my polynomial here, is there a GCF? Is there a leading negative? So definitely no leading negative. But is there a GCF? We have 3x squared negative 15x plus 6x minus 30. If I look at all 4 terms, do you see that I can actually factor out a 3? That's interesting. So I definitely have a GCF. Notice that I cannot factor an x because my last term does not have an x to give. So when we go to our flow chart, is there a GCF? We're going to say yes. So it says factor it out of the entire polynomial. After we factor it out of the entire polynomial, then we say how many terms are there. So the first thing is, let's factor out my GCF, which is 3, from the entire polynomial. Remember, when we factor out a GCF, that is the same as dividing this factor from each term. 3x squared divided by 3, x squared. Negative 15x divided by 3, negative 5x. 6x divided by 3, positive 2x. Negative 30 divided by 3, negative 10. Good. Next, it says how many terms are there. Now, what this is implying is if you did have to factor out a GCF, you're looking at what you're trying to factor. So in this case, how many terms are there essentially in the parentheses, right? 1, 2, 3, 4. So because we have a 4-term polynomial, we are going to factor by grouping. Not a bad flow chart, eh? So what I'm actually going to advise you is I want you to take your finger and cover up that 3. I always have my students physically cover up their GCF in the very beginning, because what ends up happening is that by covering it with their finger, it's not distracting from the rest of the problem. And then what it also does is it reminds us to include the 3 in our answer. So we say, we're not going to forget about you. I'm just going to hold on to you and cover you up because you're distracting. Okay, so I've covered up the 3 with my finger. Next, I have my 4 terms, so I'm going to factor by grouping. Factor by grouping. I'm going to look at the first 2 terms and the last 2 terms. Out of my first 2 terms, I have a GCF. Notice I have x squared minus 5x. If you just close your eyes and hear x squared minus 5x, you heard the word x, right? So we are going to, or the letter x, we're going to factor out x from both terms. That leaves us with x minus 5. Double check. X times x is x squared. X times negative 5 is a negative 5x. Your sign always comes down. Get used to it. That sign will always come down. So we have a 2x minus a 10, and notice it's a positive 2x. So 2x minus 10, I can factor out a 2. If I factor a 2 out of both terms, that leaves me with x minus 5. So I went from 4 terms to 2 terms. Now I need 1 term, and we do that by factoring out the x minus 5. So if you take x minus 5, bring that out. Notice you're dividing both terms by x minus 5, which means you're left with x plus 2. Notice that my finger was covering up the 3. That was our GCF from the very beginning. This is the only thing I was covering up. So that 3 cannot be forgotten. We're going to bring that right down and place it in front of our factored form. And this is my final answer. Now, let's say you don't believe me, right? Let's say you're like, nah, this is a magic trick. So I'm going to check my answer to prove that to you. So I'm going to rewrite my solution. 3 times x minus 5 times x plus 2. You can do this in multiple ways. If I were you, I would actually just multiply your binomials first and then distribute your 3. So wait to the end to distribute your 3. So we are going to apply what we've learned from chapter 6, and we're going to multiply these binomials. X times x is x squared. X times positive 2 is positive 2x. Negative 5 times x is negative 5x, and then negative 5 times 2 is negative 10. This whole thing is being multiplied by 3, correct? So we multiply the binomials, and we still have to multiply by the 3. So now I distribute the 3 throughout. 3x squared plus 6x minus 15x minus 30. Take a look at this polynomial. Take a look at our original. And ta-da! We can say check. Even though the order of the terms were different, so positive 6x and a negative 15x versus how it began, it's still the same polynomial, right? Because the sign stood with that particular term. So you have to keep that in mind, that it's okay if these two are actually in reverse order. It's not a big deal. It's the same exact expression. Let's do it again. Let's take a look at number 2. So we have negative 2p squared minus 16p plus 2p plus 16. Step number 1, is there a GCF? Is it a leading negative? So if you look at each of these terms, first off, you know there's a leading negative. So I'm going to factor that negative out. Now, we're going to look at each of these terms, numeric and variable part. So 2, 16, 2, 16, I can definitely factor out a 2. P squared p, p, no p, okay, I cannot factor out a p. So my very first step is to factor out a negative 2 from every single term. So if I divide each term by a negative 2, I'm left with p squared. Negative 16p divided by negative 2 is positive 8p. Positive 2p divided by negative 2 is a negative 1p. Positive 16 divided by negative 2 is a negative 8. Okay, hopefully so far so good. Good morning, Ria. No worries. Let's cover up the negative 2 because that's my GCF. I want to hold it on the side. I don't want it to be distracting, so I'm just going to keep it right there. Notice I have 4 terms inside of my set of parentheses, so I'm going to factor by grouping. So factor by grouping. And remember, that's 4 to 2 to 1. So let's go through the process. Look at the first 2 and the last 2 in terms of groups. Out of the first 2 terms, you're going to factor out your common factor, which is p. If I factor p out of both of these 2 terms, I'm left with p plus 8. Your sign always comes down. So in this case, it's a minus. No big deal. Bring that sign down. Next, if you have a negative 1p and a negative 8, your GCF here is going to be leading negative. And then notice the only number you can factor out is a 1. So negative 1. Negative 1p divided by negative 1 is a positive p. Negative 8 divided by negative 1 is a positive 8. Double check. P squared plus 8p, negative 1p, negative 8. Whenever you're factoring out a negative, always double check the signs. Signs are always that sticky point where, oh no, something can go wrong. Make sure you're double checking. It's too easy to do a quick check, so you might as well. 4 terms, 2 terms. Now we're ready to finish this off by factoring one more time so that we have one term. My GCF here is a p plus 8. If I divide both terms by a p plus 8, I'm left with p minus 1. And then, of course, now I'm going to raise my finger up and I say, oh, I was holding on to my negative 2, which was my GCF. So I'm going to bring this negative 2 down and put it in front of my answer. And there is my final solution. That is my factored form. Okay? As a reminder, you actually should check. For instance, when you're taking an assessment, when you're completing homework, check your work. This section especially is super nice because for 99% of the problems, when you're factoring, if you redistribute and you get the original, you've done it correctly. The only 1% is where you forget to factor out that GCF. But maybe the rest of the process was perfect. So just be careful, right? Make sure you're factoring out your GCF first and then factor according to the number of terms, which is why I have the flow chart, which is why I keep pointing that out to you, okay? So let's do the check and then we'll try another problem. I'm going to go ahead and write out my answer, negative 2 times p plus 8 times p minus 1. Again, I'm actually just going to distribute the binomials. You could have distributed the negative 2 to this parentheses, but you would not distribute the negative 2 through the second parentheses. Think of it this way. Negative 2 times p plus 8. This parentheses says where you start. This one tells you where you end. So if you did distribute the negative 2, it only goes to start, stop, the first set of parentheses. It does not continue through the second, which is why I just prefer to multiply the binomials first. P times p is p squared. P times negative 1, negative 1p. 8 times p is 8p. 8 times negative 1 is negative 8. Bring the negative 2 down, and now all we have to do is distribute. So we get negative 2p squared, positive 2p, negative 16p, positive 16. Let's double check. Negative 2p squared, 2p, negative 16p. Here it is, positive 16, and check. We're done. Try number 3. So 3 says 3x squared y plus 7xy minus 15xy minus 35y. Give this your best shot. As soon as you have your answer, go ahead and throw that into the chat. Good luck. Okay, let's take a look at this one. So the very first thing we do, thank you, Doc. The very first thing we do is we say, okay, do I have a greatest common factor? I look at each of the terms and I say, okay, let's look at the numerical part first. I have a 3, I have a 7, I have a 15, I have a 35. I do not have a common factor other than 1 that can be factored out of all 4 terms. So I'm going to move on. But remember, every term has a numeric and a variable part. So let's take a look. X squared, x, no x. All right, well, that won't work. But then notice I have y, and another y. So my GCF in this case is actually y. So first things first, I'm going to factor the y out of every single term. Remember, what that means is we essentially divide each term by y. And if we do that, notice these y's are going to end up canceling, right? So that leaves us with 3x squared plus 7x minus 15x minus 35. So that's the very first step. We factored out that y. So now I'm going to cover it up so that it's not distracting. And this is when I go through the process of factoring by grouping. I hope you've noticed that I keep writing factor by grouping because as we move through these problems, I want you to say, oh, I'm going to use this technique for this problem and this other technique for that problem. So it's going to be helpful to identify that and get into that habit now. So let's take a look at the first two terms and the last two terms. From your first two terms, notice that numeric part, we do not have a GCF other than 1, but a variable part, we can definitely factor out the x. So if I factor out x, I'm left with 3x plus 7. Double check. X times 3x is 3x squared. X times 7 is 7x. I love it. You're always going to bring that sign down, so I'm going to bring down the negative. But more than that, if I have a negative 15x minus 35, my leading term here is negative. So I'm going to factor out a negative and then look at the numeric part. Do you see how we can factor out a negative 5? Notice the variable part. I cannot factor out an x because this term does not have an x to give. So if I factor out a negative 5, let's take a look. Negative 15x divided by negative 5 is a positive 3x. And then negative 35 divided by negative 5 is a positive 7. Double check. Negative 15x, negative 35. Awesome. We just went from 4 terms to 2 terms, and now we need to factor one more time so that we are left with 1 term. My GCF for these 2 terms is 3x plus 7. I'm left with x minus 5 in my second set of parentheses. And then, of course, if I lift up my finger, I say, oh, I had my GCF here, which was y. So I'm going to bring that right down and call that my final solution. Excellent work, everyone. Noelia, Cindy, Doc, fantastic work. Kevin, you were getting there. You just needed to include the other parentheses. It doesn't go away. You have to keep that in your answer. So excellent work. Yes, Doc. Very, very nice. That concludes factoring 4-term polynomials. Not bad, right? You factor by grouping if you have 4-term polynomials. What we're about to learn is what happens when we have a trinomial, right? So specifically, I want to look at trinomials whose leading coefficient is greater than 1. So I'm going to present to you a general form for quadratics. So I'm going to present that form to you, and then we're going to identify what those variables represent. You'll see what I mean in a moment. And then I want to teach you how to factor using this technique. So again, this is going to be another problem where you're just going to watch and then copy down. It's going to be really important for you to just take it in, okay? And again, if you're watching this at a later date, just pause the video after I finish explaining so that you can copy everything down. And Patrick, no worries. I'm just glad you're here. Let's take a look at the next technique. If you have a trinomial whose leading coefficient is greater than 1, then you are going to use AC grouping method. Trinomials of the form ax squared plus bx plus c, where a, our leading coefficient, is bigger than 1, will be factored using AC grouping. Keep in mind the flow chart. We still start with, is there a GCF? If there is, you factor it out of the polynomial. How many terms are there? Then you're going to say, oh, I have 3 terms this time. It's a trinomial. And then you're going to say, is a greater than 1? Oh, it is. So I'm going to factor by using AC grouping. This is where we are right now in our flow chart. Okay, just to make sure we're all on the same page, what values in the following trinomial represent a, b, c? So if I write ax squared plus bx plus c directly above this polynomial, you will all see that a is equal to 12. Wow, did I just say that? You will all see that a is equal to 11, b is equal to negative 9, and c is equal to 2. That should be the very easy part. Being able to say, oh yeah, I have a trinomial of the form ax squared plus bx plus c. I know what a is, I know what b is, and I know what c is. Awesome. It is time for you to put your pens and pencils down because I am going to illustrate to you how to factor by using AC grouping. Okay, let's consider the following polynomial. 2y squared plus 7y minus 15. According to my flowchart, I need to look to see if there's a GCF first. So I'm going to look at each term, numeric part and variable part, and I'm safely going to say no, there is no GCF. So then I'm going to note that there are no, right? So there's no GCF. How many terms are there? It's 3 terms. This is a trinomial. And then notice that my leading coefficient, my a, is greater than 1. So I'm going to use AC grouping. The method I'm going to use here is AC grouping. Now check this out. The word itself, the name itself tells you what to do. AC. AC. This is not A plus C. This is not A minus C. This is definitely not A divided by C. So when A and C are connected like this, that means multiplication. Okay, so knowing nothing else, I'm going to say let's start with A times C, because that's what it says in the name. A is 2, and C is a negative 15. When I multiply 2 times a negative 15, this gives me negative 30. Now I start to think about this and I say to myself, okay, well, I took A times C, I multiplied it, I got negative 30, but what in the heck do I do? And then I look closely and I say, I used A, I used C, but I did nothing with B yet. That's interesting. So I want you to make a note that B is a positive 7. So what we want to do right now, and I'm going to try to illustrate this in different ways throughout our notes. What I'd like to know now is when I make those factor pairs that we did earlier, which one will result in a positive 7? Which pair will result in a positive 7? So I'm going to write out the factors. 1 times 30, 2 times 15, 3 times 10. But notice I need a negative 30. Now when I combine these, I want to get a positive answer. So if I want to get a positive answer, do you all agree that essentially when I combine them, that your larger number should be positive and your smaller number should be negative? Let's test this out. Negative 1 times 30 is a negative 30. Negative 1 plus 30 is a positive 29. That is not the same as 7, so this is not the one we want. We have negative 2 times 15 is a negative 30, but negative 2 plus 15 is a positive 13. And that is not the one we want. Keep in mind that this is our goal. Our goal is to find the one that gives us 7, so that's not it. Next, I have negative 3. Good morning, Wada. Negative 3 times 10. Negative 3 times 10 is a negative 30, and negative 3 plus 10 is a positive 7. Voila. Ding, ding, ding. We just found the match. So here's what we do. Since we have just found that negative 3 times 10 gives us a negative 30, and negative 3 plus 10 gives us 7, then what we're going to do is we're going to rewrite this so that I can then factor by grouping. Recall that if you want to factor by grouping, you need 4 terms. But we only have 3 right now. So we're going to fix this. Negative 3 plus 10 is 7. Maybe I can take this 7y and replace it with these 2 values of y. So meaning, what if I write 2y squared minus 3y plus 10y minus 15. Let me just make sure I got this right. So I took the 7y and I replaced it with these 2 factors, so negative 3y plus 10y, which actually works because negative 3y plus 10y is 7y. But I've taken a trinomial and I've turned it into a 4-term polynomial so that now I can factor by grouping. Okay, so I think the hardest part is this section right here where you say, okay, a times c, that gives us negative 30. And then you say, well, I left b out, so I want to find factors that combine to give me b. So let's do that. We'll find factors that combine to give me b. And then you say, well, I need to make this a 4-term polynomial. So why not replace my b term with the 2 factors that I found? Once I have this in the correct form, I can now factor by grouping. Out of the first 2 terms, I'm going to factor out a y. If I factor the y out, I'm left at 2y minus 3. I always bring down the sign in between, so I bring down that plus sign. From 10y minus 15, I'm going to factor out a 5. I'm left with 2y minus 3. And then I could write my factored answer, which is 2y minus 3 times y plus 5. And that is your solution. Again, if that's freaking you out, let's do a quick check. We have 2y minus 3 times y plus 5. All we have to do is distribute to make sure that we did this correctly. So we have 2y squared plus 10y minus 3y minus 15. Then combine like terms. 2y squared plus 7y minus 15. And we have the original polynomial. Good. Take a couple minutes, write this down, digest this information, make sense of it. 2 minutes starting now. Now, what I've done for you all is I've actually written out the process for AC grouping method. So let's say you're at home, you don't have access to the video to rewatch it. You can just follow through these steps to identify how you factor using AC grouping. So give that a shot, take a look. Hopefully that is very, very clear and that it sounds almost like what we talked about. It should sound identical to what we talked about just a second ago, okay? But I want to try one more problem with you before I let you go. Factor completely, check your result. So we have 16y squared minus 4y minus 2. Let's go to our handy dandy flow chart. You remember that Blue's Clues? So steps to help you factor polynomials. The first thing, is there a GCF? Is it a leading negative? Take a look. 16y squared minus 4y minus 2. Aha! I definitely see that I have a GCF of 2. So I'm going to factor that out first. If I take a 2 out of each term, I'm left with 8y squared minus 2y minus 1. Perfect. So I factored out my GCF. Done. How many terms are there? It's a trinomial. Take a look. 1, 2, 3. And my leading coefficient is an 8. So that means I'm going to use factor by AC grouping. So I'm going to cover up the 2. We go through this process. I'm going to write AC grouping. And then I'm going to go to town. So A times C. A, B, C. 8 times negative 1 is going to give me negative 8. And I want factors of negative 8 that give me B, which is a negative 2. So let's write down the factors. 1 times 8, 2 times 4. Note that our goal is to get a negative 2. So when you look at these two numbers, the larger number should be negative. So we have 1 times a negative 8 is a negative 8, and 1 minus 8 is a negative 7, and that does not meet the goal. For my second pair, the larger number gets the negative. 2 times a negative 4 is a negative 8, and 2 minus 4 is a negative 2. Check. So now I'm going to circle these two factors, because what we're saying here is that when 8 times a negative 1 gives you negative 8, you note that 2 times a negative 4 will give you negative 8, and 2 minus 4 will give you a negative 2. So we're going to replace this b term with our two factors that we have found. So we rewrite 8y squared positive 2y minus 4y minus 1. Do you see how the only thing that got changed was my middle term? I wanted to rewrite it as 4 terms so that now I can factor by grouping. Double check. 8y squared, yes. 2y minus 4y is a negative 2y. Awesome. Negative 1. Good. Now let's factor by grouping. First 2 terms, last 2 terms. Out of my first 2 terms, I notice that I have a 2y, right? Numeric variable. I'm going to factor out a 2y. That leaves me with 4y plus 1. Double check that. 2y times 4y is 8y squared. 2y times 1 is a positive 2y. Bring down your negative sign, your minus, because a negative 4y minus 1, my factor here, my GCF, since my leading term is a negative, is going to be a negative 1. If I factor a negative 1 out of both of these terms, negative 4y divided by negative 1 is a positive 4y, and negative 1 divided by negative 1 is a positive 1. So we went from 4 terms to 2 terms, which means we need to go to 1 term. So I'm going to factor out my 4y plus 1. That goes away, and I'm left with 2y minus 1. And I lift up my finger, and I notice, oh, I factored out a 2 from the very beginning. So my GCF has to go right in front of my answer. And that concludes problem number 1. What I would actually like you all to do is I want you to do number 2 and number 3 on your own. Let me show those to you right now. That way you have them. If you don't have the notes, you can just go ahead and write down the problems. And we're going to take a look at those on Thursday when we come back. There's no class tomorrow. So let me show you problems 2 and 3. Number 2 is negative 14x squared plus 46x minus 12. And then number 3 is 6p squared plus p minus 5. On that note, I am going to let you all go. Give those a shot. See how it goes. I'll check in with you on those 2 problems on Thursday. So keep those handy and make sure you're doing your Lumen work. All right? Enjoy the rest of your day. Enjoy how beautiful it is. Get out there. Enjoy it. Okay? See you, everyone. Nice job today.